This, 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 5. And this, 4, 6, 7. Into my function. If you are using the left rule, you would f of 3 times 0.4. And you would say f of 3.4, put it into a function. Multiply by 0.4, etc. What if you are using the midpoint? What? You just need to find the midpoint here, 3.2. 3.6. Put them into the function and multiply by the thickness. Thickness still being delta x. Or, if you have no idea how to find midpoints, take the average. 3.4 plus 3 is 6.4. 6.4 divided by 2 is 3.2. That into the function, multiply by delta x, you will get that over there. Same here. Take the 3.4 and add to the 3.8, that's 6 plus 7.2. 7.2 divided by 2 is 3.6. That is to say, find your midpoint on that interval and you will have n of them. Find the midpoint on that interval. Evaluate the function there, multiply by the thickness and add them all up. In other words, add all n of them. Now you can do however you want to find the midpoint. You can just say, well, on the ith interval, this is the delta x. This is the I interval. In other words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the I interval, this would be xi minus 1, and this would be xi. If you want to know the midpoint, you will take the average of those two. The midpoint on the ith interval would be the average of those two. That's another way to do it. But you have to do it with the x's in your hand, depending on what they are. Okay. Now you can make these more accurate by making n larger. The larger you make n, the more accurate your approximation will be. That is to say, when you let n get large, you will make delta x small. If b and a are fixed. If you're integrating between 3 and 7, you could break it up into 10 pieces. Or you could break it up into 100 pieces. You will have a larger n with 100. You will have a smaller delta x with 100. In other words, there are more calculations. Now, these schemes, the left rule, the right rule, the midpoint rule, they have their advantages and disadvantages. Now, depending on your function, who is to say which one is the best? There may be some functions where the left rule is approximating better than the right rule. There may be some functions where the right rule is approximating better than the left rule. Depends on how your function is changing. And likewise, there will be times where the midpoint rule is better, but typically the midpoint rule tends to do better than both. That is generally speaking. We can talk mathematically about what that means. And we know why the midpoint rule tends to do a better job. If you look at the concavity of your function, if you look at the concavity of your function, let's say you're trying to approximate that area, and let's say we broke it up into 4, and you are using the left rule, you can see why this is inaccurate, because you're undershooting by that amount. Now, however, if you were to use the right rule, you will see why that will be inaccurate, because you're overshooting by that amount. And you'll add them all up. Your answer will be over what you really want by that amount. And you do the midpoint rule. You say, well, now, let's not take the value, let's not take the height on each interval from the endpoints. Let's take the height on each interval there. In other words, the height at the midpoint x on that interval. And here you have overshoot, and here you're undershoot. So it was kind of compensate. But you still won't be exact. As you can see, you're really overshoot. You're really undershot here. But not quite as bad as the left rule or the right rule. So we've broken this problem into a grade 7 problem. You give this to a grade 7 student, they can do it. You just need to give them the heights and say, if you want to find the height, put these x values into the function and get them. And thickness, well, thickness, just take your interval and divide it by n and you get the thickness. And they say, okay, good. Right, so for example, this may be 0.25. And the height here would be 2, and the height here would be 2.5, and the height here would be 2.7, and the height here would be 8.9. So take 2 multiplied by 8. I have them all. There you have it in calculus. They would be approximating these functions. This integral. Well, they have no idea what that means. So you are playing there with rectangles, which your typical middle school student knows.